Now we move over to integration formulas. If u and v are functions of x and a, b, c, n are constants, we have the following integration formula where the constant of integration has been omitted. Therefore, normally there should be a constant of integration that will be added to this integration formula, but we are omitting it, focusing only on the result of the integration. So if you integrate this, you are going to have integral of u with respect to x plus or minus integral of v with respect to x. That is, you integrate them separately. If you integrate cu, you're going to have this c integral of u with respect to x. C is a constant, so you bring the constant outside, then integrate the coefficient of x, which is u. That's why we have c integral of u with respect to x. If you integrate u with respect to v, this is an integral by parts, and the formula for integral by parts is u multiplied by v minus integral of v with respect to u. Again, if you have this kind of integration, it is called integrating by parts. And to integrate by parts, the formula is u multiplied by v minus integral of v with respect to u. That is why you have uv minus integral of v with respect to u, integration by parts. Then if you have this, integrating this, you have integrating x to power n with respect to x, you have x raised to power n, the power will increase, that is x raised to power n plus 1 all over n plus 1, where n is not equal to minus 1. But when n is equal to minus 1, integrating this x raised to power minus 1 with respect to x, remember x raised to power minus 1 is the same thing as 1 over x. So integral of 1 over x with respect to x is the same, will give you natural log of x, ln x. Integrating this a raised to power bu with respect to dx. A is a constant, b is a constant, u is a coefficient of x. Therefore, you have a raised to power bu over a raised to power bu all over b multiplied by the natural log of a, where a is not equal to 0. Integrating this e raised to power ax with respect to x, we have the inverse of the constant, which is at the power, multiplied by the whole equation. That is why we have 1 over a multiplied by e raised to power ax. Integrating cos x with respect to x, you have sin x. Integrating sin x with respect to x, you have minus cos x. Integrating tan x with respect to x, you have minus natural log of the absolute value of cos x, which is equal to natural log of the absolute value of sec x. Integrating cot x with respect to x, you have natural log of the absolute value of sin x. Integrating sec x with respect to x, you have natural log of the absolute value of sec x plus tan x. Integrating cosec x with respect to x, you have natural log of cosec x minus cot x. Integrating sec squared x with respect to x, you have tan x. Integrating cosec squared x with respect to x, you have minus cot x. Integrating 1 over square root a squared minus x squared with respect to dx, with respect to x, sorry, you have sine inverse of x over a. Remember, differentiation is an inverse of integration. That's why if you differentiate this, you have this. If you integrate this, you have this. Integrating 1 over square root a squared minus x squared with respect to x is equals to sine inverse of x over a. Integrating 1 over x squared plus a squared with respect to x will give you 1 over a multiplied by tan inverse of x over a. Integrating 1 over x square root x squared minus a squared with respect to x will give you sec inverse of x over a. Integrating this 1 over square root x squared minus a squared with respect to x will give you natural log of the absolute value of x plus square root x squared minus a squared all over a. Integrating sine bx with respect to x will give you cos bx. Integrating cos bx with respect to x will give you sine bx. So that's all for integration formulas. What I need you to do here is take your time and try to understand each of these integration formulas, because it will be used while solving ordinary differential equation.